Today we are going to start our new topic, that is properties of fluid. Okay, properties of fluid, and we are going to start this one to know what are the characteristics, what is the nature, and what is happening inside the fluid, right? So if I will differentiate between your solid, okay, and your fluid, right, there is a basic difference are there, that is your fixed in shape. Who solid is fixed in shape, fixed in volume, but in case of your fluid, that is quite different. Okay, but most important point that you people have to remember is this one. Okay, what is that? Suppose here you can say some atoms are there here present inside the solid. Okay, and you can see here two kind of forces are present. Okay, what force? The force, if this is a surface, you can see, okay, this molecule, okay, can apply a force on this one. Okay, as you know that they are all binded with the interatomic forces, right? So if you can observe, if you will take this one as the reference point, okay, and this molecule as the force point, or you can say where you can apply the force, okay, then this atom is applying a force on this one. Okay, this atom is applying a force on this one, right? So this is known as perpendicular force. Okay, this force is known as perpendicular force. This force is present in case of solid, right? In case of liquid also it is present. As you can see, this is the liquid diagram. You can see here also it is present. How? See here, this is the surface of the liquid. Okay, this is one of the atom, okay, who is applying the force on this particle, okay, or this molecule, right? So they are in intact with each other, right? So this force is present in fluid also. Okay, this force name is perpendicular force. This force is named as perpendicular force. Next one is, here in case of solid there is a tangential force is present, right? Any force that is present in the tangent, you can say that is a tangential force, right? So here the tangential force is also present. What is that? If you can take these two molecules, here the interatomic force is present. Because of that they are intact with each other. Okay, they don't want to separate. Okay, you have to apply lots of force, then only it is going to separate, right? And they are binded with a interatomic force, and this force is known as the tangential. As you can see, this force is present in the tangent. Okay, in the tangent you can see, if this is the molecule, this is the molecule, they are intact with each other with this force. This force is known as the tangential force. But the only change is that in the liquid the tangential force is absent. What is absent? The tangential force is absent. Okay, if you will take this one, these molecules here in case of a liquid, and if you will check the force, okay, the force of tangential is absent between the two atoms. Okay, the force of tangent is absent, or tangential force is absent between two molecule in the liquid, right? And because of that it is easy for the top surface molecule to flow. Okay, it is easy for the top surface molecules, water molecules, to flow easily. As you can have obviously observed that always water flows from the top. It is not going from the, if this is the drop of water, you can see it always starts to flow from the top side, right? As because you can see here the tangential force is absent, because of that it flows easily. It starts to flow from the top surface. You have to remember this word. It starts to flow from the top surface, right? Why? Because tangential force is absent. Okay, this is the only change. Okay, perpendicular force is present in both the case. And what force is absent? The force that is absent is tangential force. The force, this one, is present here. In case of solid it is present here, but in case of liquid it is absent, right? So the tangential force is absent, and because of that the water molecule starts to flow from the top surface, right? So this is the simple thing that is in the fluid. Okay, that is the only difference. Okay, now let us go in deep and let's see what is specific density. Okay, as we know very well, what is density? mass upon volume. Okay, we know it very well, mass upon volume. But why we take specific density? Okay, the specific density we are taking because we have already the materials present in our earth is having with different units. Okay, right? Some are, if you are going to a gold shop or gold jewelry shop, you are not asking for 5 kg of gold, right? You are asking for some grams, right? Because it costs lots, right? Okay, lots of money. So you are asking like that. Okay, so various matters or various particle in the earth is having different kind of units. Some are in pounds, okay, some are in kgs, okay, and some are in what you can say grams and something else, right? So if I want to compare between the two materials, okay, if I have to compare between two materials, suppose one side I have some gold and the other side I have a heavy iron or something else, right? Or I am having a very small particle like uranium. Okay, uranium is a very small particle, and the other side if I have any other particle heavy metal, okay, then there is a obviously there is a difference in the unit, right? And if I want to compare their density, then I have to go for the specific density case, right? Because the unit is different. So right, so what I will do, I will just compare the density of that particular material, suppose uranium and iron, okay, uranium and ferrum, that I want to compare. Then what I will do, I will take the uranium density, okay, the density of the uranium, and divide with the water. Okay, I will take the uranium in whatever unit it is, suppose it is in pound. Okay, so I will take in pound the uranium, and the water in also I will take in pound. Okay, I will take the same thing, okay, and I will compare it with water density. Okay, uranium density and water density. Okay, so what will happen, the both the units will be cancelled. Okay, both the units are going to be cancelled, and you will get a number, okay, or a ratio, right? You are going to get a number. That number or that ratio is known as the specific density. That ratio is known as the specific density, right? And why we are taking this one, because we need to compare two different materials with different units, right? So what we have to do, we have to compare with a known quantity, right? As you are going in day to day life, you are going to the shopkeeper, and with the help of a fulcrum, he is putting this side a known quantity, and with the other side with the unknown quantity, or you can say which thing you want to measure. Okay, obviously one product has to be known, otherwise you cannot measure it, right? Here also the simple fundamental is being used. What is that? You have to take the density of the material, okay, and divide it with the water, okay, with the water's density of the water, you will get a number. Okay, for uranium suppose I got a number, suppose 1, and for ferrum I got a number 3 by 2. Okay, this is 1 by 1, and here I am getting 3 by 2. If I will compare with the water, I am getting the number 3 by 2 or something else, right? So here I can compare the specific density of uranium is 1 and specific density of ferrum is 3 by 2 or something else. Okay, so what is specific density? In order to compare two solids, it may differ in units, that is in kg or in pounds. So it's quite difficult to find out the density comparison. So you use the concept of specific density. So what is specific density? You have to find out the ratio of density of the material to that of the density of the water, right? And you can say, so it will give you a number. You can see, so it is a number because the units are being cancelled due to division. Okay, now density of the material is what? If I want to find out density of the material, okay, if I will find out density of the material, then I can also found high specific division multiplied with this density of water will come here, will be multiplied here. Okay, then I can find out the density of the material. If I know the specific density and I know the density of water, then obviously I can find out the density of the material, right? So what is density of material? Density of water multiplied with specific density, right? And water, it's a known quantity. What is that? 1 into 10 to the power 3 or 1000. Okay, but in sea water this is 1.03 into 10 to the power 3, just 0.03. Okay, it will be given in some questions, but water's data will not be given in the numerical, right? You have to remember it anyhow. Okay, clear everybody? Switch on your mic and say me yes. Everybody switch on your mic. Okay, right. So now let us find out what is the pressure by the fluid, pressure applied by the fluid. The same formula, that only it is a force generally applied by the fluid to the container, right? If you will place water inside a container or some liquid material inside the container, so obviously what pressure this water will give to this container, that is known as the pressure by the fluid. Okay, this water is now going to give some pressure to the container. Obviously this water doesn't want to stay here, it always want to flow, right? So it always will apply a force to its boundary. Okay, so that is the pressure applied by the fluid. But what is pressure? Pressure formula is force upon area, right? Force upon area. And what is the relation here? P equal to F by A. That we know it earlier. P equal to F by A. Now see this term clearly. Area and pressure. Suppose one battery is there, okay, and here is a holding part, okay, and here iron is there, okay, in the holding where you have to hold, where you are going to hold, here a iron material is there. Now when you are going to pick it up, or when you are going to locate to somewhere else this battery, obviously you are going to get a pain in your palm, and obviously in your palm a line will be drawn like this, okay, with a red color, right? Because this is because of what? Force upon the unit area. As you can see here, as the force applied by this one, okay, and or you, whatever you have applied, okay, and this area is very less here, okay, as you are observing here, the area is very less. Okay, now what should be the pressure? If the area is very small, you are going to get a pressure very large, and because of that in your hand you will get a pain in the palm, right? And there will be a line drawn in your palm. But if you are going to touch this one, or you are going to lift this one with the help of a towel, okay, or any sponge or something else, what you are going to do? You are increasing the area. Now in your palm the lots of area is coming, that is in the form of foam, or you can say that is in the form of what you can say sponge, or in the form of towel, that is coming as a area. Now you are increasing the area. If you are going to increase the area, the pressure is obviously going to decrease. So if the pressure will decrease, now no line is going to drawn, okay, in your palm. Okay, you are not going to get any pain while holding or lifting this one, or placing this one from one side to the other side, right? So this is a clear definition. Okay, pressure is inversely proportional to area. My purpose of saying these things is to identify you what is the relation between force, or you can say what is the pressure and area relation. These are already a what you can say inversely proportional. Okay, but force and area are directly proportional. Like you can write this one, this term, then this will be F equal to A, then this will be F by P. Okay, area is directly proportional to force. If you will increase the area, okay, then the force will be also high. Okay, so this is what the pressure by the fluid. Okay, now here we are going to discuss another term, what is Pascal's law. Okay, this is very important. And one more thing you people need to remember, that it's having what you can say, it is having direction in all the side. Okay, pressure is having direction. If you will keep a water inside the balloon, obviously the water is going to apply a pressure in all the direction, right? It is going to apply a pressure in all the direction. So you can say it is having a scalar quantity. Obviously it is having a scalar because it is giving you a magnitude value, but there is having a direction in all side. Okay, so you cannot say it is a vector quantity, right? As it is having a not having a single direction, you can say at a time it is giving multiple directions, right? So that's why it is given a name tensor quantity. Okay, its quantity is known as not a vector, it is a tensor quantity, right? The quantity was discovered this one as it is going to apply what you can say pressure in all the direction, so it is known as tensor quantity. Okay, right. Next point is Pascal's law. What is Pascal's law? You can see pressure inside a fluid at every point is same. Okay, what is Pascal's law? Pressure inside a fluid at every point is same. Okay, what is that? Pressure inside a fluid at every point is same, acts in all direction, and it is normal to the surface in contact. Okay, let's see in detail. It's a very easy thing. You can remember it easily. Okay, if you will take a balloon like this, okay, and you will fill this one with water, okay, and if this is going to apply a pressure, okay, this water is going to apply a pressure, and obviously you know it, this pressure is going to be applied in all the direction. Okay, it is going to be applied in all the direction, because whenever or wherever you will puncture, okay, wherever you will puncture this balloon, you know it, the same pressure is going to come. Okay, the force will differ, the area of puncture will differ. This doesn't matter that you will puncture this much only, somewhere you will puncture like this with bigger area, somewhere you will puncture like this. Okay, so area will differ, but the ratio will always come the same. What is the ratio? P equal to force upon area, right? If you will increase the area, suppose here the area is 1, okay, let me give the example. If here the area is 1, okay, and suppose the pressure here inside, pre-calculated pressure is suppose 4, okay, so this force is again 4, okay, so here the area is 1, okay, force is 4, so what the ratio we will achieve? You will receive 4 upon 1, answer is 4, okay, this side 4. Now at this point I will take a bigger puncture like this. Now area I am making double. Okay, area I am taking here area as 2. Obviously the force is also going to be doubled, right? Here it was 4, so here it will become 8, right? So now let us find out force upon area. This will be 8 by 2. Again it is going to give you the answer 4, right? So this is what, this is practical. Theoretically I am explaining, practically also you can observe the force will differ, the area will differ wherever the you will make the puncture, that doesn't matter, but the pressure will remain the same. Only maintain that one. Okay, maintain that one and keep that one in your mind. The pressure that will come out from a particular product will remain the same, because the pressure is same inside. Okay, suppose the pressure is 4 here inside, obviously the 4 amount of pressure will come outside, right? If the pressure is 4, obviously the 4 will come, not 5 or 6 or anything will come, right? Puncture, it is all depending upon you. Okay, at what instant and what angle, or what you can say what distance you are make to go doing a puncture or something else, right? So this depends totally on the force upon area. Which one? Pressure. Okay, and the simple thing is that the pressure is same everywhere. Okay, that was told by the scientist Pascal. Okay, no doubt, if the force area, if you change the area, force will increase, but the ratio will be same in all the side, whether it is a bigger puncture, whether it is a smaller puncture. As the pressure is 4 inside, so obviously the 4 amount of pressure is going to come outside. Okay, whatever is inside, that much only will come, no extra data is coming outside apart from that, right? So this was told by the scientist Pascal, right? And also you can observe this one by applying this concept to a hydraulic fluid machine. Okay, here you can see I have drawn a diagram here. Okay, and you can check here what I am going to do. Suppose this side a container is like that, okay, and here a piston is present. Piston means a moving piston. If you have seen the syringe, vaccination is going on, right? You can observe it. A piston is there inside, okay? And if you will press this one, this injection part, okay, if you will press this one, force, apply the force, this piston is going to move, okay? This piston is going to move. The same thing is here, okay? So what I have drawn here, you can see clearly there is a small aperture like this, okay, I have taken, and this is the piston, and inside that the fluid is present with the help of this one connector, okay, and the other side I have taken a bigger container like this, okay, bigger container like this, and this is the piston of this one bigger container, okay. Area 1 is supposed to be 1000, let us take it 1000, and area 2, okay, let's take a unit area, very small area, equal to 1. And what I have said, the pressure inside the fluid or pressure inside the container or pressure remains same in a particular product, okay. Particular object is having a particular pressure, it is not going to be changed. So inside this container, wherever the pressure is always same inside, okay. The pressure will be same inside this connector, okay, up to this part, okay, up to this part the pressure is going to be same, right? Suppose I have placed here a force of 1 kg, okay, how much? 1 kg. And now as we know the principle, P equal to, pressure formula is what? Force upon area. So let us place it. This is, let's take is this is F1, suppose, and this will be F2, okay, F2 upon A1, okay, or you can take it as A1 this side, okay, I have changed, interchanged, this is A2 and this is A1, suppose, let's take it, okay, this is A2 and this is A1, okay, and this is force 1, okay, and this side this is force 2, okay. Now what is going to happen here, I have placed the F1 equal to 1 kg, 1 kg block I have placed inside, or 1 kg of force I am going to apply by my foot, okay, to this part, okay. This is a, what you can say, suspension, or you can, whenever, if you are going to keep the pressure on it, what will happen, this is going to move downward, okay, and going to give a pressure to this liquid part, okay. If I will place a 1 kg, what is going to happen, this particular product will go down and going to give a pressure on this piston, okay. Now this piston is going to apply a force on this water, okay. This is the thing that is going to happen, okay, right? So what is the pressure formula here? I can apply, as I have given the name, you can write it, pressure is equal to, I can write, this is suppose F2, force F2, this is F2 upon A2, and here pressure is equal to F1 by A1, right? And I know it from the Pascal's law, the pressure will be same here, right? Now if it is 1 kg, okay, let's find out P, pressure. This force is 1 kg, this area is 1 kg, so F1 upon A1, 1 upon 1 is going to give me the answer 1, okay. So pressure of 1 is going to move through this pipe, okay. This pipe is now carrying a pressure of 1. Why? Because I am altering by applying a force of 1 kg, right? So pressure applied here at this part, at this terminal, is equal to 1. This pressure is now going here to this terminal, okay, this terminal, right? Now let us see in detail. Here how much pressure is coming? Here the pressure is coming as 1, okay, and what I have taken the area A2 and force as F2, okay. Pressure I know 1 and area I have made as 1000, okay. How much area I have made? 1000, okay. Now let us find out here the formula, okay. Let us find out the force 2 applied by this fluid to this suspension, okay. Here the suspension is there, okay. Now here this liquid part, okay, this pressure of 1 is going to apply a force of how much to this one? Let us find out that one only. The force F2 is equal to, formula is a reverse one, okay. What's the formula? Because pressure formula is what? Force upon area. Then what is force is equal to? Force is equal to pressure into area, right? So what is the pressure here? 1. what is the area here? 1000. Area is 1000. So what is the force? Force is 1000. What is the force? 1000. So see here clearly. This liquid is going to apply a force of 1000 to this container, or you can say to this suspension. So obviously, if you are going to place a car of 900 kg, okay, see here, you are going to place here a car of 900 kg. How much? 900 kg. And here how much force you are applying? 1000 kg. So who is bigger? This one is bigger and this one is less. So obviously this car is going to lift. Are you getting my point? If you are, how much force you have applied? With a very small amount of force. How much? 1 kg. How much is the area? Very small amount. But you are able to lift a 900 kg of car. How? Because the pressure of 1 is creating a force of 1000. Right? And you can observe here the pressure of 1 when it will come here, okay, as you according to the formula, force upon unit area, that is pressure, then force equal to pressure into area, then pressure is 1 multiply with area of 1000 is going to give you the force of 1000. And this 1000 force is being applied from down to top, from this what you can say piston to this suspension, right? And now here the car is present and car is applying a force of 900 and this one is applying a force of 1000. Obviously the car is going to lift. Okay, so this is the case that is happening here, and we are using this principle of pressure, as the pressure is same everywhere. Okay, and we can lift up any kind of material through this concept, and this concept is applied everywhere. You can see it in case of what you can say car also. We are using hydraulic brakes, right? A liquid, you can see a liquid brake at when you will go to the service station, they are using the liquid fuel, okay, or you can say fluid they are using in order to apply the particular fluid material to the brake container, okay, and that is used to stop the car at instant. Wherever you will apply the brake, at that in particular instant it is going to stop. Okay, in disc brake also this concept is now going to be used. Okay, now this is known as the hydraulic brake, because you are going to give a pressure with your leg is very less, but you are going to achieve a heavy amount of stop, okay, with that